Okay, you guys, welcome back. In today's lesson, we are going to be covering section 2.2, which is entitled Graphs of Equations in Two Variables, Intercepts, and Symmetry. Okay, so by the end of this lesson, you should be able to complete the following objectives, which include graphing equations by plotting points, find intercepts from a graph, find intercepts from an equation, test an equation for symmetry with respect to the x-axis, the y-axis, and the origin, and know how to graph key equations. Okay, so that's what we're going to be able to do at the completion of this particular lesson. Okay, now in this section, we are making the assumption that you guys do not know what particular graphs look like. So we are introducing a concept called graphing equations by plotting points. So most of you guys are familiar with the XY coordinate system. Okay, so in this particular situation, we have two variables. We have level of risk that is measured in percentage, and we also have average annual returns, which is also measured in percentage. Okay, we know that from our experience with graphing. Okay, 1 minute. All right, the variable that is going to be on this horizontal axis, that is our x variable. Okay. All right, some people will also call it your independent variable. And the variable that is along this vertical axis here, that is our y variable. And some people will also call it your dependent variable. So anytime you are graphing, what you are actually doing, you are showing the relationship between two particular variables, just like in this particular picture. So it's showing you what is happening to the average annual returns when you are manipulating the level of risk. So when I say that you are manipulating the level of risk, usually the variable that we are playing with, that we have control over, is the independent variable. Your y variable is your dependent variable because it depends on whatever your x is. Okay, so in this section, we are going to be looking at graphs. We're going to be looking at particular points and then graphing them. Okay. All right, so this first equation that they give us, they want us to graph the equation y equals 2x plus 5 by plotting points. Okay. Now, some of you are going to be able to look at this equation and automatically tell that this is a linear equation. Therefore, the shape that it should make is a line. But like I said, the book and the publisher are assuming that you have no idea what particular shape this equation is going to make prior to you plotting it by points. Okay. So what they mean, that whole concept, what we're going to need to do, we're going to have to pick some x values, and then from our x values, we're going to have to find some y values, which are going to give us our coordinates, and then from our coordinates, we're going to be able to graph our particular equation. Okay, so I'm going to go ahead and make a table for our variables. Okay, so like I said before, our x variable is our independent variable. So that means I have the freedom to choose whatever value I want for x. So I could plug in a negative value, I could plug in 0, I could choose something positive. The choice is completely up to me. So for the sake of simplicity, I'm going to try 1 for my first value. Okay, so in order for me to find my y value, that means that everywhere there's an x in this equation, I need to plug in 1 in its place to find y. So what I'm going to do, I'm going to say y equals 2 times 1 plus 5. Okay, when I do that calculation, 2 times 1 is 2 plus 5, that gives me 7. So that means when I plug in 1 into this equation, 7 comes out as my y value. So as a coordinate, that corresponds to the point 1, 7. That means that particular point is going to be on my graph. Okay. So I'm going to choose something else. Let's say I choose 2. Okay. I'm going to do the same exact thing. So I let 2 be equal to my x. So that means in this equation, everywhere that I see an x, I'm going to plug 2 in its place. So I'm going to do the same exact thing that I did before. So y equals 2 times 2 plus 5. I'm going to go ahead and do that calculation. So 2 times 2 is 4, and 4 plus 5 is 9. So that means when I plug in 2 in this equation, 9 comes out. So that corresponds to the point 2, 9. Okay. So I have some points now. Let's just do one more for good measure. Don't have to worry about it. So I'm going to go ahead and plug in 3. Okay. So I'm going to do the same thing. I'm going to plug 3 into that equation. So 2 times 3 plus 5. 2 times 3 is 6. 6 plus 5 is 11. So that last point I have is 3, 11. Okay. All right. So remember, our whole goal was to be able to graph this equation. So I have some points now. All right. So let's see if I can graph those. So I have some grid paper here. So I'm going to go ahead and draw my coordinate system. All right, so that first point that I had was at 1, 7. So remember, in a coordinate, that first variable position tells you which way to move, either left or right. Because I'm moving 1, 7, that 1 tells me go to the right 1, and that y position tells me to go up 7. So 1, 1, 2, 3, 4, 5, 6, 7. All right, and I'm going to put a point there where those points meet. All right, so there's my coordinate 1, 7. All right, I'm going to go ahead and do my second point, which was 2, 9. All right, so that means I'm going to go to the right 2, and I'm going to go up on my y-axis 9. So I already have 7 dashes there, so 8, 9. Going to go ahead and plot my second point. And remember, we did this third point here for good measure. So I'm going to go ahead and do that one. That point was at 3, 11. All right, so I'm going to go to the right 3, and I'm going to go up 11. I'm going to go ahead and plot that point as well. All right. And now, since I have my 3 points, I can go ahead and connect those dots. All right. And there's my line. All right, I plotted it. So awesome. That's all they're asking us to do. Find our coordinates and then graph our line, just like we did. So we are all set for that problem. All right, so let's go ahead and look at the solution. All right, so we didn't do so bad. So as we can see, their particular points that they chose -5 for their x. They chose 0. They also chose 1 and 10. Does not matter. Remember, if you're plotting by points, you have the freedom to choose whatever values you want for x. And then all you need to do is plug them into your equation to solve for your y values. Okay, but as you can see, we came out with the same picture. All those points lie on the same exact line. So we're good.